Welcome to our webinar, Improving Vessel Operational Efficiency with Data Analytics, OSV case study from our sponsors, Opsealog. Our guest speaker today is Stanislas ORIOT, Senior Marine Consultant at Opsealog. If you have any questions about the topics today, please type them in the Q&A section and we'll get them answered for you at the end of the presentation. Here is our host, Carl Jeffrey from Digital Ship to explain more.
We're here today to talk about new ways to use digital analytics to improve maritime operational efficiency. And we've got a case study about improving efficiency of offshore support vessels operated by Brunei Shell. We're going to talk about how to use data analytics to understand the operational profile of the vessel from an energy consumption perspective and how to develop best operational practices. And there's some ways that energy efficiency projects might be easier for offshore support vessels or OSVs. So OSVs aren't traveling all over the world and they usually have a single long-term customer. It might be easier to improve energy efficiency in distinctive time-limited projects with OSVs. That can be easier to do. You can seek to achieve a return on your investment in a specific time scale, such as 6 months. And then you can do it that way. You can keep the company's support for what you're doing by showing that your projects are working. You can determine specific actions which need to be taken to deliver the project and determine who's responsible for them, so you can make sure they get done. So this project-based approach might be better than chipping away at the problem continuously over 20 years, which is sort of what many shipping companies are doing. We've got a speaker today who's got a background as a mariner and then working in a shipping company purchasing department. And he's also trained in both data science and energy. So he's the only person I've ever met with such a strong background in all the domains which come together in improving vessel performance. I thought he may be the only person in the world who's done all of these things, but he's a bit modest. He doesn't like it when I say that. But Stanislas ORIOT is Senior Marine Consultant at Opsealog. He's sailed on container ships, oceanographic vessels, and offshore supply ships. Then he worked on shore as a technical purchasing assistant with Marseille Fret, a company that manages container ships and ro-ros. Then he did an MSc in Global Energy Management and Systems Technology at Strathclyde Business School. And his company Opsealog is based in Marseille in the south of France, and they specialize in maritime data integration and data management and connecting vessels with digital tools. So the presentation is going to be about 25 minutes and there should be plenty of time for questions. So I'd like to invite Stanislas to start his talk. Thanks.
Thank you, Carl. Hello, everyone. I hope I will live up to the expectations of Carl. So I will present how data can be used to improve monitoring and efficiency, especially for offshore support vessels, because that's my main domain knowledge, and that's the domain where Opsealog works. But even more importantly, I will talk about how data is not a silver bullet and how proper data project management can be the real game changer. And I will end the presentation with a real use case with Brunei Shell Petroleum, one of Opsealog's clients, and how they reached more than 6% of monthly fuel savings just with a software and data science. So my goal here is more about raising questions and starting conversations than educating you. I'm sure many of you in the audience are more knowledgeable than me on various topics that I will raise during my presentation. So I will go on with the presentation and I look forward to the Q&A part. The background, I'm not gonna go on about it because Carl did it in a better way that I would do it. And during the presentation, I will draw inspiration from my experience at Opsealog. So I've been there for more than 5 years. We started as a very little company. When I arrived, we were 6, 7 people, and now we are almost 50. So I grew with the company and the company grew with me as well. I may mention the company several times, but just to be clear, it's not an ad for the company. It's just to give the right context to what I'm going to talk about. So operating vessels, especially offshore support vessels, is more costly than ever now. PSV daily rates are more than $30K US. So it represents more than $11 million US yearly for one PSV, excluding fuel. and we know that's a big expense as well. So all of this represent more than 200% increase in price compared to 2021, so just 2 years ago. And there's also a lack of new vessels. One of the reasons being high interest rates, especially in the past year or two. So it's becoming more expensive to build ships. Also, we're having more and more regulations, especially on the part of environment emissions of the ships. And there's been, for the past few years, even though it's getting better, we've had regulations with a lack of visibility in the future. So ship owners and shipbuilders don't really know where to go in terms of design. So we have more and more vessels that are staying in the market for longer, and it highlights the importance of efficiency. And in terms of costs, we need to include the fuel, but also future costs regarding emissions. Offshore support ships are going to be under regulations for emissions as well in the near future. So that's really important to keep in mind. So I talk about fuel, but fuel is just the end part. It's one part of the efficiency scope. We have several scopes under which we need to work to improve vessel efficiency. We have structural issues with the types of ships, the kind of retrofits to do, how to do it, when to do it, and new types of propulsions, new types of fuels and energy sources. In terms of maintenance, we need to think about hull cleaning, when to do it, how to do it, with which type of product, and the kind of impact it has on a ship fuel consumption. Engine maintenance itself has the same kind of problems, but it's also related to operational optimization, which has to do with how much idle time the ship is gonna have, what is the engine load of the ship during different kinds of operations. And we all know that's a big issue with in the offshore sector, because we often operate at low loads or even very low loads that can impact in a bad way the engine operational ability. So when we talk about data, we need to talk about what to do with it. And so at Opsealog, what we start by doing what we call a screening period. That screening period helps us get a baseline of data, of indicators for how a ship is operated. So we get new data, but also data history if possible, AIS tracking and Iridium tracking, AIS by satellite, etc. And we combine all of that to get a full picture of how the ship is operated when we start working with it. Then, or in parallel, we build what we call a fuel consumption model. So we estimate the fuel consumption at the operational level and not just at the daily or voyage level. And it's very important for offshore support vessels, because there's not only transit and import operations, there's a lot of operations happening offshore, inside the 500 meters, outside, etc. So we need to determine what kind of fuel consumption the ship has, depending on the engine configuration and the kind of environment that the ship operates in. So we measure all of this and we transcribe all of that into reports, on demand or automated, into KPIs on a website available for the clients, and in dashboards that are more interactive to play with the data on just one page. I just took one example of data that we can get. It's the amount of savings, of fuel savings that could be reached for offshore vessels, depending on the standby reason. So the details are not really important. It's just to show the kind of insight that we can get. And more than that, there are so many variables that we want to understand behind that simple chart. We need to know the weather in the area. We need to know if the platforms work at night, what kind of ship are involved in the operations. What am I really looking at? One chart is not enough to see the entire picture. But more concretely, what can we do with that data? First of all, you cannot improve what you do not measure. So we need to measure everything that we need. I will get back to that afterwards. And we need to determine the vocabulary that we're using. In the chart on the left, I'm using idle. It's basically standby and some other operations. But what am I including there? Did I include maintenance? Or is maintenance some kind of off-hire time? We need to define all of that, because otherwise we end up with figures that we cannot explain and we cannot act on them. So on the concrete side, what can we do? Historically, we've been improving crane sharing in ports. We improved the placement of offshore buoys, mooring buoys, to reduce the fuel consumption of the PSVs and other ships offshore. We also helped install new buoys in specific locations. In terms of shore power, do you need it? Are the ships enough in port to use shore power? You need to monitor the best practice that you implemented, or you need to implement them in the first place. Data quality, it's very, very important issue. And in the first hand, you may think that, okay, I'm going to deal with it. It's not that hard. I'm going to take some hardware, or I'm going to take some software with built-in data quality checks, but it's often not enough. Really, when you work with data, in data analysis, in data science, most of your time, more than 50%, way more than 50%, is made of dealing with data integration, data quality, and ensure you have the right data to do the analysis. The analysis part in itself is not that big of a deal when you have the right skills to analyze the data. Other concrete actions that you may take is improve the standbys, because the ships are not doing anything. So you might as well reduce the consumption of those activities to the lowest amount possible. And finally, even more complex, you may want to adjust the fleet, the size of your fleet, with more ships, less ships, or even do some benchmarks and replace some ships with newer ships or older ships, but with a more efficient design than what you already have. So I already used the term fuel several times in that presentation. We all directly thought of HFO, MGO, or maybe LNG. But in the near future, we're going to need to think about many other fuels, like methanol, ammonia, hydrogen, and so on. So it's that growing complexity that modern data science helped to grasp. The maritime world is getting more and more complex, and it grows also with the enormous amount of data that we collect. So we need appropriate ways to deal with that amount of data. And this is where I get to the second part of my presentation, being more on data management, project management, because I see it that way. Data, it's like a hammer, so it's a tool. If you don't have the people and the skills to use it, it's useless. or it's even dangerous. That's why I say data is not a silver bullet. Technology is not the answer. At least it's not the only answer. It's how we use technology, how we use data. So you need the tool, but you also need the strategy. And it's how we organize our teams. If you do a data project internally, it's how you do it internally, or how you choose and interact with your third party, like Opsealog, that will determine the success of your project. But often data is used just as a tool. And that's why we see figures like 87% of data science projects fail. So it's not always a complete failure. It's just that it doesn't deliver the success that people were expecting. And 20% of analytics insights deliver business outcomes. So that means that 80% of analytics insights don't deliver real life outcomes, real life actions. So that's why my advice is really to lead all of that as a project, data as a strategy, as a project, and not just as a tool. First, you choose a pain point you want to resolve. You determine how you're going to measure your progress and your success. Then you choose the right team. So you have an HR challenge there. You choose the right team and give them clear objectives. And maybe one thing that can accelerate your journey is to leverage third parties to help you on just one part of your project or the whole project. And maybe most importantly, start simple. You don't always need big words like artificial intelligence, machine learning. Maybe just simple data analysis could work with your problematics. So start simple, and then you may grow in complexity with your data projects. So what about the challenges? Just like the figures before, those figures are taken from consulting groups' works, analysis, real life figures from responses they got from companies working on big data projects. On the technology side, you're going to have a lack of skill set on data. So how to deal with it, how to analyze it, what to do with it. Then you're going to have to deal with the costs, the knowledge of how to integrate the data, how to store it, how to process it. And then you may have issues with security, cybersecurity, and who is really responsible for the data, who is going to deal with it, and where is it stored. We could have that issue with some countries. And on the business side, there's also an issue with the knowledge, the skill set. Is the domain, so is maritime, offshore, or the offshore sector well understood by the people who are dealing with the data? And is there a clear strategy? Is there a vision? And is it shared by everyone? And maybe you're gonna have someone wanting to reduce the size of the fleet, but some other part of the business have problems with that because they may need that size of fleet for future needs, but you don't know it. So you need to know the business requirements. You need to have a vision, a long-term vision, and that's something that we see more often now with the IMO. But in the past, we haven't seen that much clarity on the way to go in terms of regulations for emission reductions, etc. In terms of regulation in general from the IMO, and we see where we got. We have challenges in terms for emission reductions, but we're beginning to see more clearly where we're heading in the next 10, 15 years. But that's quite new. So that shows that we need clarity and we need long-term plans, a long-term strategy. And also we need a lot of communication within your company or between your company and the third party. And leaders need to know at least a little bit about data, how to use it, and what are the key problematics around it. Because we often hear that AI will replace people, AI, artificial intelligence. But AI is not going to replace managers, but managers who understand and use data analytics are going to replace those managers who don't. So we have really problematics in terms of skills, in terms of improving how we deal with all of that. And just to give you a few examples in terms of skills, in terms of jobs, what you're going to look for in your team or in the third-party team is not only people knowing about the domain, so the maritime or the offshore sector. You're going to look for people with jobs such as data engineer, data analyst, or data scientist. And finally, as I said a little bit before, you're going to need to define how you measure your cost, how you measure the success and the progress of your project, and maybe how you define the ROI, the return on investment of your project. And don't necessarily base that on fuel savings, because fuel savings is one thing. It's quite easy to measure. But in the end, digitalization and the use of data maybe it's going to bring some fuel savings, but it's not going to bring just that. It's going to bring some time available for your teams to work on more complex projects, on more interesting stuff. Maybe you're going to save some money because of fuel, because of digitalization on other topics, but not necessarily just on fuel. So fuel savings may not be your ROI of choice. I listed here a few concerns that you may have regarding this kind of project to use data for efficiency. We may come back to it later on. I will just go through it rapidly, but I already talked about a lot of them. So we have cost issues, return on investment. Will I commit to a solution for long term, for a long time, or can I go to another solution easily? How will it impact my teams? And will I keep control over the data, over the management of my fleet, or will I give that to someone else or to some other company? And who should I involve in my team? And how will they deal with the data? Is the data secure? Where is it stored? Are those people trustable with my data? And in the end, is my data accurate? Can I use it to improve the efficiency of my fleet? And also, will the digital tools that I chose replace paper? Or is it just another task for the seafarers and another distraction and something that will tire them up? And also, how do I keep up with that domain that changes really rapidly? So to sum it up, this section, how to start and how to go on with this kind of project. As I said, define your objectives. Really, it's really maybe the most important part. Define what you want to do and how you're gonna deal with the data related to those objectives. The access to the data, it's how, but also what. What kind of data do you need? Do you need just tracking data that's basically already available? Or do you need more data? Do you need reporting data? Do you need a solution that will replace the paper on board with record books and logbooks? Maybe you need the help of a third party there for that step of the way, or maybe the third party can accompany you along the whole way. And then once you have the data, it's great, but what do you do with it? Do you need to use it on a daily basis, weekly basis, or just once in a month is useful for you? And how are you going to translate that into optimization, into real life actions? And into that action step, it's really important to determine who is going to do it, who is going to talk to the ships if you need to give them some new orders, how many engines to operate for which kind of operation, what kind of speed do you want to implement in your fleet, or just for a specific ship. And then once you have optimized what you think you can optimize, you need to measure. So you go back to accessing the data basically, but with one more variable, the optimization. And then you go on and on with that, and that's a continuous project. It doesn't stop there when you optimize. You need to go back into that feedback loop. And we've had at Opsealog some clients coming back to us after a year or two, saying, yeah, we kind of let go on the measuring results part and into the optimization step. And we see that the fuel consumption is going up. It's what did we do wrong? You stopped measuring the result and you stopped implementing the actions. Even though it's the same actions on and on, you need to treat that as a project that's never ending, basically. The next step, the next slide, it's about the step on accessing the data. I'm not going to go through it completely because it's a very large subject. It's how to determine if you need hardware or software, or maybe both, because they work together, or you need to find a way to make them work together. So when I talk about software, for example, it's a reporting software for the crews to say what they did during the day, and what kind of operations they did, etc. Basically the logbooks and the record books that we know on board ships. And the hardware part may be some sensors like fuel monitoring sensors to know the fuel consumption of your engines. And there are many pros and cons for both solutions, so I'm not going to go through it. If you have any question regarding that, just type them in the Q&A section, and we will go back to it afterwards. Just a little bit about Opsealog before reaching the final slide about the use case. So what is Opsealog? So we are a French-based company in the south of France. And we're combining both data expertise and maritime expertise. So data expertise is people who know how to deal with data on servers, what kind of architecture to build to store the data efficiently. So efficiently, it means to access it easily, but also to at a reasonable cost. And maritime experts with onboard experience or onshore experience as well in logistics, in naval architecture. We operate 100% remotely. That means that we can visit our clients, but we mostly work in our offices. So there's basically no cost associated with that. And we build solutions that are basically custom made for our clients. We have an interface that's common for all of the clients, obviously with the right with the correct rights for everyone to access just the data that they can access. We have dashboards for everyone, but also custom made dashboards and reports that are available 24/7. And how do we feed that? We feed all of this with data from AIS, from Iridium, from hardware such as fuel monitoring systems, but also a reporting software that's available both on cloud and as a software, proper software that's installed on the computers on board the ships. We have data quality checks that are made inside the software, but also in the office by real people, because sometimes that's necessary. And all of this is integrated in one system with a common vocabulary that streamline the whole process of integrating and using the data. So finally, the use case that I wanted to talk to you about is about one of our clients, Brunei Shell Petroleum. Sorry. That has now a 60 vessel fleet that we are monitoring, and they reached for 2023 a 6% average of fuel savings per month. It started at 10% during the first year, but it improved. The operational practices improved right from the start with the new ships. So it shows that BSP, Brunei Shell Petroleum, BSP, is implementing best practices right when the ships enter the fleet now. They don't wait for us to do the screening period and to give optimization actions. The operator is already more skilled and autonomous thanks to the collaboration and the data that we collect and provide. So what did we do with BSP? First of all, we gave visibility on the ship's activities. People on shore now know the operational profiles of the ships. Excel reporting was really hard to use for analysis. It was many different files, maybe filled in different ways by people on board the ships. So Excel reporting was replaced by proper data reporting in dedicated software. And we centralized the operational data collection for BSP. So everything is available really easily for them. So what does that bring? Better monitoring. Then we can customize the best practices, the best operational practices by ship design, or even by ship, because some ships that are sister ships may have different types of constraints in terms of speeds, in terms of engines that they can use, depending on the situations, or even sometimes depending the maintenance that was done on the ships, the hull fouling, the engine maintenance. We need to integrate that into the analysis, into the best practices. All of this is monitored by our teams, but also by the client team autonomously. And we meet on a weekly basis to discuss some specificities of the fleet. Some best practices that may need to be reminded to the crews or to the onshore teams. So what did we do concretely? Like one example. In terms of offshore standbys, there was a high rate of DP. So we helped minimize that. And when possible, depending on the weather and the situation of the ship, we helped optimize the use of existing mooring buoys. And we also helped installing about a dozen new buoys in strategic positions. So to reduce the standby fuel consumption to the minimum possible. And we continue to adapt to the new ships that enter the fleet. We continue to benchmark each ship against each other and against new ships that may enter the fleet to help BSP reach even higher fuel savings and CO2 emissions reduction figures that reached more than 22,000 tons during our collaboration in the past few years. If you have any additional question about that, you may ask them in the Q&A. Just know that I may not be able to answer them all because of confidentiality issues. So finally, what can we take away from everything that I just said? Fleet digitalization and the usage of data with performance go hand in hand. You can have a centralized way of collecting information, get rid of Excel or old solutions that may not bring about this kind of centralization of information, and it will improve the data quality, data processes, best practices processes in your operations. Both charterers and ship owners can benefit from data-driven efficiency strategy, and I even add other stakeholders that may not be operating or owning ships. Fleet optimization, as I said, is a continuous effort. It's not just a one-time effort. It requires technology, measurement, analysis, and a continuous follow-up. But even more importantly, it involves people and leadership. So your success depends on how you can leverage your data, both on the technology side and on the management side. And finally, don't be scared to get help from third parties. Sometimes you get in the mud trying to do everything by yourself, but other people already encountered the kind of issues that you're encountering. So just ask for help from third parties, whether it is someone like Opsealog or other ship owners or other charterers that may help you and save you some months or even years of struggle. Thank you very much. I guess that by the number of people that are attending, we've been having many questions. So I guess back to you, Carl.
Wow, well, thank you very much. Well, that's great. Yeah, if you'd like to stop sharing your screen now. And yeah, so we've got questions, pretty much the same question. So this is from Chris Pemberton, who's Director of CP Maritime in Perth, Australia, from Nixa Kacic, who's with BW LNG in Greater Oslo, and Shane Biggie, who's in London, but they're all asking about your data collection. So Chris is saying your preferred source of fuel consumption, I suppose EFMS is electronic fuel monitoring systems. Nixa Kacic is asking, how do you collect data from different data sources? Do you collect them on board together, or do you send them all separately to a cloud system? Shane Biggie is asking, what frequency do you collect vessel data? I mean, this is what Opsealog does. You're a specialist in this, isn't it? But I guess maybe...
Yeah, so I'm not going to be a specialist about the whole data chain. So the data engineering part is not really my thing. So that's about storing the data, integrating it into databases. I'm mostly a user of data, so I can talk about it, but I can talk about the sources. First of all, I want to highlight that the data quality is never gonna be perfect. So yes, we use reporting data. So from the crews, they input the fuel consumption of the ship on a day-to-day basis. We know that's not perfect because a ship moves on the sea, and even at port, it's not perfect to report the data like this. So you may say, okay, we're going to use the sensors on board, but the sensors on board are mostly accessible on board. You're going to have even sister ships. You're going to have various systems to get the data. So we could build APIs so basically digital interfaces to get that data from the ships, but we would have to do it on a ship-to-ship basis. So that would be a lot of work. I know there are some initiatives in the world, and there's been some initiatives for a few years to improve that collections from existing sensors. We know there are many sensors on board the ship, so why not use it for that kind of reason that's very hard to get. You may use some new sensors like EFMS. You have some providers of EFMS. Maybe there are some in the audience, so I'm gonna be reasonable about it. Sometimes it works, and when it works, it's really great. You measure the consumption not only on a day-to-day basis, but maybe as precise as a second. So you really know what your engines are consuming and what kind of fuel flow you have when you're loading or offloading fuel. But just like any sensor, it's not perfect. You're gonna have maintenance issues. The ship cannot go back to port. You cannot have someone intervene on the sensor to calibrate it. So you may have some data issues. You're not gonna get the data or proper data at some point. So in the end, the most reliable, in my opinion, I may be wrong, is reporting from the crews. But that's why we have some people in-house who know what an engine is, what kind of consumption that engine should have, what kind of consumption those ships should have. And we compare what is reported, what is collected by EFMS to our in-house algorithms to determine if there's an issue somewhere. And we can also benchmark one ship against another to see if there's something that's going wrong. And sometimes that may not be data quality. Maybe that's the ship needs some maintenance. The engines are dirty, or maybe the hull is dirty. So there are many variables, but just to summarize, to answer the question, where do we get the data? Regarding fuel reporting 100% of the time on a daily basis from the ships. EFMS, so from sensors. And we also estimate the fuel consumption on an an operation basis, depending on the number of engines, the weather, etc. So many variables.
Well, so coming into Nix's question, so he's asking if you've got different data sources on board, do you have a central data collector on the ship and send it all to the shore together, or do you send each data source separately to a shore cloud system? Or are you just talking about one sensor, a single fuel consumption sensor?
So we're more on the data integration part. We mostly get all of these through different channels, directly from the ship or indirectly through third parties. We store them on the cloud, and then we access it through one channel that's in-house, but from the cloud. And that's really one of the big challenges, is getting everything into one streamlined data system where everything makes sense, even though it comes from various sources. And even EFMS, you're gonna have several providers, and all of those providers do not provide the same naming for the data, the same granularity for the data. Some of them give data by the second, others by an interval of 10, 15 minutes. So we have to make sense of that. And I guess other questions may arise about cloud storage and cybersecurity. I cannot reply to all of the questions there because it's not my domain. But what I know is that every year at Opsealog we have external companies testing our systems. So it's called penetration tests. It's basically hackers, but who work for the common good. and they try to enter our system, and they give us a note on each domain, so the reporting software, the client interface online, and they try to access that through there, and they give us a note on each domain, and also recommendation on how to improve that. So for now, what I know is that we do not have any cybersecurity issues. We do not have any history of cybersecurity issues, but it's just like data management projects, we have to work on that continuously. We know we cannot have some kind of Maersk data issue like some years ago, where almost the company almost crashed down because of data cybersecurity issues.
Well, I mean, the big challenge everyone's having is getting data from the ship, by the look of it, from the questions.
Yeah, and just to be clear, I'm not criticizing Maersk there, because I don't know the subject perfectly, but everything is moving so fast that we have to keep up. We have to update our machines all the time, and we have to be conscious of this every minute of the operation.
Oh, so we've got another question here. This is from Harsuk Singh, who's following your steps. He's an ex-second engineer with Dynacom. Now he's doing research in Kuala Lumpur, but he's asking about anomalies in the data. I mean, it's amazing to me how many problems people are having. I don't think people have problems like this in their cars when they're telling you how much fuel you're using. But I guess so. The question is, how do you help in pinpointing the cause of extra fuel consumption? Well, that wouldn't be an anomaly. That could be a problem in the real world, or a I guess, yeah. Well, actually, yeah,
but
that's a different question.
Yeah. I see what the question is about, and how do you pinpoint one or few reasons for a fuel consumption anomaly? And first of all, you have to know whether it's a real anomaly. So if you have a higher fuel consumption than usual, or if it's a data quality issues. And the data quality issue is the first thing that we check, because we cannot go on in analysis and say to a client, okay, we think that the higher fuel consumption than usual is because your hull is dirty, and you need to go into dry dock and clean that hull. And actually they go into dry dock and see that the hull is perfectly clean, and we basically are idiots for saying that. So we need to check that it's not a data quality issue. That's why we have many sources for the fuel consumption, and then we're gonna cross-check many types of data inputs, from engine running hours to operations to other things like comments that the ship may enter. And sometimes you can highlight data quality issues just by something that's completely off, but in another sector of the reporting. Let's say comments that do not make sense. 24 hours of transit, when we know, thanks to the AIS or just by common sense, that the ship did not do 24 hours of transits. And from that, we're gonna think, okay, so if there's a problem there with some kind of simple reporting like that, maybe I have issues with some other things in the reporting, like fuel consumption. So we have the chance to have account managers in-house who are the face of Opsealog for our clients. Our client do not contact a support team like that. They have someone with a name, with a face. And those people, those account managers, are in charge of contacting the onshore teams and the crews on board to ask any question if there's something. Yes, we would like to have something that's 100% reliable, 100% trustable in terms of data quality. But right now, we are all humans. We make mistakes, voluntarily or not. And we have to deal with it. Up to now, we do not have I cannot answer this kind of question from where can we have issues of fuel consumption, whether real or not real, in a simple way. And I think that if he's a second engineer asking that question, I think he already has many ideas in mind. On the engineer side, engine maintenance, low load of operation, or on the bridge side, high speed, low speed, and so very low load on the engines, or just simple as weather and current and so on. Many variables there.
Very good. So we've got a question from Chris Pemberton in Perth. I don't think you can answer this specific question because he's asking about Brunei Shell, but perhaps we can answer in a general sense. So
let's try.
Well, he's saying, so if the ship is required to have an electronic fuel monitoring system on board by the oil company, then why are you also going to use crew reporting? I think you said earlier you find crew reporting more reliable than even quite advanced electronic systems,
Yeah.
is it? But
yeah.
you can have both then.
So EFMS is great when it works. And I'm not saying it doesn't work more often than it works, but sometimes it does not work. So we need something else to rely on. We often have those questions about why do you get manual reporting about engine running hours, fuel consumption, operation, etc., when you could get something from AIS, EFMS, etc. But first of all, manual reporting is reliable because it's done by some people. People are not 100% reliable. They can make mistakes, but they're gonna report. The EFMS, if the EFMS did not measure something at 7 o'clock today, it did not measure it. You're not gonna go back in history to get that data. So that's, I think, the main reason why we get reporting data. So for the moment, all of the manual reporting data, including Opsealog, are not approved by classification societies. We started that process with the BV for some of our record books, like the garbage record books, the oil record books. But we do not have that for fuel consumption reporting for now. But it's in the books, and we believe that we're gonna get that certification, and it will replace paper. And for now, paper reporting is compulsory. You need to do manual reporting. So why not get it for fuel consumption?
Oh, very good. Well, one thing that struck me, so a lot of the things you were talking about, I thought they can't possibly result in maybe big fuel savings like moving buoys around or changing the speed. But then you talk about this 6% savings. I thought this is kind of what the real world vessel performance looks like. It's kind of not obvious or very small things and a lot of messy data. But at the end of the day, I guess 6% is worth all the effort, isn't it? So I suppose.
Yeah, and we need to also mention that it's 6% on quite large amounts. It's 6% of 5-10 tons a day. So that's not minimal. Obviously, we would like to have bigger fuel savings, but we need to understand the context as well. It's just with data coming from software, some hardware, there's no additional cost apart from the data management part, the data integration, storage, and data analysis. And also there are quite some large variations because you may have a very small figure on a ship that already operates well from a very mature ship owner, and you may have issues with less mature ship owners or less mature crews on board the ships operating the ship in DP, maybe for safety, just for safety reasons, and that's how they were taught. And we have a lot of hours of standby in DP, and we convert that into standby at a mooring buoy. So we go from, let's say, 200 liters per hour to a 50 liters per hour consumption. So you're gonna, every hour you're gonna reduce your fuel consumption by 150. 10 hours, it's already a ton and a half. So we have some fuel savings figures of 20-30%. It's not the case most often, but yeah, I generally we get, let's say, 7, 6, 7, 10% average.
Oh, I mean, one thing that strikes me, so I really can tell your background in both the data and the mariner side. And if you're going to say to a crew, you need to use the DP less, or I think you can use the DPP less, they've got to trust you as a mariner. But it's not practical for shipping companies to recruit people who are both mariners and have studied data science, I suppose. I don't know what you're.
Well,
perhaps...
actually, I did not study data analysis or data science. I used it a little bit during my master's.
Okay.
But as I said in the beginning, I grew with Opsealog. I started knowing barely anything about data analysis. I grew with it and I saw the opportunity behind it. And yeah, I continue to grow with it. Yeah, it's maybe it's not common, but it's gonna get more and more common with people from a maritime background going onshore. And I think that we have, and when I say we, it's seafarers in general, whether you're trained in France as both an engineer and a bridge crew, or if you're specialized, you have so many skills on board that can be used in a maritime company, in an energy company, in a consulting service. So many resources on board. And we know that basically after 10 years after studying, there's only 30% of graduates who continue to work on board ships. So you have 70% of graduates available with maritime knowledge, available for maybe data analysis.
Yeah, that's great. Well, we're coming towards the end. I mean, another thing that sort of struck me, because the levers, because you had that lovely slide at the beginning where you talked about the levers being the structure, the maintenance, the operation. I thought very little of that is actually within the capability of a performance manager. You probably can't change the fleet itself or the type of vessels they've got in the fleet. You probably can't do much about maintenance, but you can perhaps advise on the whole maintenance. You can do a little bit on speed, but you probably can't change the buoys around. But then even with that small amount of levers you have as a vessel performance manager in a company, you still can manage 6% improvement savings if you are very good at working with data and monitoring things, I guess.
I mean, 6% is on topics that are quite easy, let's say, to deal with. It's improving the speed of the ships, but not that much, and mostly standby offshore. And they have the chance in Brunei, Shell Petroleum, to have mooring buoys. That's really a game changer when you can install them, because if you're working in Angola with several hundred of meters of water, you're not going to install a mooring buoy. But maybe you have other ways of improving the efficiency. And just going back on speed, we often say, and we often hear in the media, that the best for the shipping world, offshore sector and other sectors, container ships, etc., is to reduce the speed. It's not that easy, because the engines, first of all, are made to operate at a certain load, so at a certain speed. If you reduce the speed, you're going to reduce the load, and maybe you're going to have dirtier engines, a need of maintenance on a more regular basis, and higher fuel consumption on each of your trips.
Yeah, that's
and
great.
also it brings about the question of collaboration between the teams, because what I talked about is maintenance and fuel consumption. That's technical, but you're going to have questions about logistics as well, because you're going to reduce the speed. that's great. That can be great, and that can be the solution. But you need to ask your logistics team if that's all right, because you're not gonna have the same availability in-port and offshore if you reduce the speed. You need to work with everyone in your teams to determine if that's possible. Reducing the number of engines and going to a mooring buoy to standby, that's kind of easy, actually. You need to monitor it, you need to implement it, but that's kind of easy.
Well, that's fantastic. Well, we're out of time now, so I guess we'll finish there. But I think my sort of finishing thought is that you made a great talk about how to combine domain expertise and some good looking at data and some very clever decision making and finding stuff that works and stuff that doesn't work. And this is what vessel performance really looks like at the sharp end. And thank you very much. So I shall pass back to Farah for the closing words. Cheers.
Thank you to our guest speaker, Stanislas ORIOT from Opsealog, and to all our viewers. We'll be sending you a YouTube video link soon with contact details if you have any further questions. Join us for our Vessel Info webinar this Thursday, 12th of October, Integrated Modular Digital Components for Vessel Performance, Part 2, working with vessel data, which you can book online at our website. Goodbye.
Well, cheers. Bye-bye.